So
Yes, yes.
when we talk about errors are broadly speaking divided into two types: systematic and random errors. Systematic errors are due to some factor which can be avoided, which can be minimized. Remember, errors cannot be 100% omitted. It can be minimized. So the systematic errors are those errors which can be minimized. In the systematic error, we have operational errors, we have personal error. Operational and personal errors, these are interrelated terminologies. Sometimes the personal error is something which is related to operation, and you are not following a proper operational procedure. So this also comes in a personal error. The second type of error is instrumental error. Sometimes you are not using proper instrument for measurement, or the instrument itself is not calibrated, so your observations are not coming correct. Then third way is errors of methods. You are using wrong methods in errors. And then the fourth type is additive or proportional error. You can read this information in detail. You will find out what are different types of errors. For example, I give this picture, operational or personal error. You are using, you are putting your eyes on the wrong direction to find out the measurement of a pen, okay? So the result will be different. So this is operational or personal error. Okay. Then instrumental error I talk, methods error I also talk, additive or proportional errors. Errors doesn't depend on constituent present in determination. Loss and weight of crucible which precipitate is ignited. Proportional depends on amount of constituent impurities in standard compounds. Sometimes you keep a solution or chemical and it is not covered. Some humidity or water and make it contaminated, and your chemical is not effective for the use. These are kind of additive or proportional errors. Now we are talking about what does mean by uncertainty. Uncertainty, for example, here you see this picture I downloaded from somewhere, and look at this thing. In the first case, by measurement, uncalibrated thermometer you used. And by the process thermometer touching the bottom of the beaker, that is also wrong. So these are kind of systematic error, is example of systematic error. You can minimize this error. Okay. Now we are talking about uncertainty. Uncertainty is mean that we are not certain, we are not 100% sure about something. For example, we are taking beaker and pipette. Leave this cylinder. And beaker, we want to measure the liquid. You see the green. Now we can say that it is 24 ml or 25 or 26 ml. Okay, because here we are not sure. So uncertainty is plus minus 1 ml. It can be 25 or 26 or 24. Do you get the point? Hello?
Yes, yes.
Yes, yes, sir.
In the beaker, now you see the liquid is there. So we are not sure about this. Is it 24, 25, 26? So uncertainty is plus minus 1 ml. Now look at the pipette. And the pipette, we put the water here. It is 1.1, 2, 3, 4, 5, 6, 7, 8. 8.3, 1.83 or 1.84. We are not sure about this thing. Up to 1.8 we are sure. So what is uncertainty? 0.01 plus minus. 1.8 we are sure, but 0.03 and 0.04 we are not sure. So it is uncertainty 0.01 plus minus. Do you get the point? Check the beaker. Uncertainty is 1 ml. Okay. Here, the uncertainty is 0.01 ml. So what we understand from uncertainty? While measurement, we have to use the tool which is more calibrated, so we can find out the measurement more accurately in that case.
So do we have to define uncertainty or do we have to calculate it?
Yeah, uncertainty actually it is a, when we broadly saying it is a kind of error. And this error is depending on kind of instrument we are using, that we are not sure. So while you are measuring small amount, you have to use more calibrated tools like pipette. If you are measuring something in liters, so you can use the beakers. No need to use the pipette for finding accuracy 0.01 plus minus. So,
Okay.
any question regarding uncertainty? Something we are not sure. So we conclude here that for smaller quantities, we have to use the instrument which are more calibrated. Calibrated means which has more lines. Okay. And for higher quantity, we may use the tools which are not calibrated even. So uncertainty in such cases is higher in beaker, and in case of pipette it is almost not there. Now, positive constant determinant error or negative constant determinant error. For example, the effect of constant determinant on analysis of sample containing 50% of analyte, 50% of weight by weight analyte. Now, if the mass of sample is 1, so what is the 50% of 1?
0.5.
0.05. It is 0.2. What will be the 50% of 0.2?
0.05.
0.1.
0.1. If it is 0.4, what will be the 50%?
0.2.
If it is 0.8, what will be the 50% of it?
0.4.
So half of this. Is it clear? Now the error
No,
in
Mr. 0.100, the half, it's 0.50 should be.
it is 0.1, not 0.1,
Yes.
so it is 0.050.
Point-
Take
0.05,
0.1
yes,
divided
right.
by 2, so you will get the answer. Hmm?
0.05. Barak.
Just look at this and you will see.
Wait. Ah, okay, yes. Sorry. Okay, clear.
Clear? Now,
Yeah,
the
thank you.
constant error in all cases is plus 0.01. Okay? 0.01 plus in all cases is the same. So in the first sample, obtained mass will be 0.050 plus 0.01. It is 0.06. Huh? This is plus constant. I'm not talking about minus. So the obtained mass will be this, added this will be 0.06. So the obtained concentration of phenolite is 60%. How we calculate 60%? For example, in if sample 1, this is 0.06 multiplied by 100 divided by some mass sample. Obtained mass multiplied by 100 divided mass of sample. What is mass of sample? Hello?
0.1.
0.1. Okay. What is obtained mass?
0.06.
0.06 multiplied by 100 divided by 0.1 is a 60%. So it's a 60%. What about sample 2? What is obtained mass? Yalla.
11.
11.
No. 0.1.
0.1 plus
0.11.
Yes, 11. Yes.
Divided by
Yes.
0.1.
First, what is obtained mass here?
110.
110. 0.110.
So it will be 0.11. Good. What will be the obtained
Yes.
concentration?
Will be 90.
110%.
Obtained mass will be 0.11 multiplied by 100 divided by 0.2. So it will be what is
Divided by 2. Why 0.2, teacher?
because the mass of sample is 0.2, no?
Will be 45.
Okay.
Okay.
0.01. $55.
Yes, excellent. What about third one?
Fourth one, 20. $52.5.
Okay. What about the fourth one? Fifth one?
Fourth one,
Okay. Khali wali. This will be 60, 55, 52, 51, 50.
51.25.
Okay.
Correct.
So this is the values coming. 60, 55, 52, 51, 50. Is it clear?
Clear.
Now look at this
Yes, clear.
mass of sample. When you are increasing mass of sample, the percentage obtained is getting near to the 50%, which is expected mass. What is expected mass? 50%. So when you are increasing the mass, the expected mass, the obtained mass is getting near to the expected mass. Do you get the idea?
Yes.
Yes.
How you can minimize this error? By increasing the mass of
Again, teacher.
How can we minimize constant determinant error? By increasing the mass of
Sample.
sample. Allah yakhalik, Allah barak.
Peak.
Peak.
Good. Now, come to the negative error. Mass of sample is 0.1, expected is 0.05, as we know. Constant error is negative. So obtained mass is 0.04 because 0.05 minus 0.01 is 0.04, and obtained concentration is 40%. How the 40% will come? How the 40% will come? Obtained mass that
Multiply by 100.
More than.
multiply by 100 divided by mass of sample is 0.1. So it's a 40%. What about this one?
500.
Again.
Now, obtained mass is 0.04. How you find out 0.04? Because 0.05 minus 0.01, so it's 0.04, correct? And how you
Yes.
find percentage obtained concentration? Obtained mass 0.04 multiplied by 100 divided by mass of sample is 0.1.
45.
The next is 45. The other will be
Other will be minus 0.1 multiplied. 47.5.
47. Allah yakhalik, Allah barak feek. Now look at the values. 45, 40, 45, 47, 48, 49. Which one is closer
Yes.
to 50?
Number of
49.4. 49.4.
So it means when we increase the mass of sample, we can minimize the errors, constant determinant errors. Okay. We can also describe in a graph for the positive constant error. If you look at the table, positive constant error, the mass of sample was 1 and percentage was 60. Okay. Then mass of sample was 2.2 and the percentage was 55, correct? When the mass of sample was 0.5. Agulak, I draw everything and I took a long time to draw this in. This is not available in anywhere. So 0.4. So you see the graph is going down and this is near the expected value. So when you increase the mass of sample, your result is coming near to expected values. You can minimize the errors in it. Allah khalik, Allah barak. See, this is positive error and this is negative error. You can see these both cases. It's very clear. Negative constant errors and positive constant error. One is going up, other is going down. Here the graph in exam will come like this. You have to elaborate the graph, why it is coming down, what is coming up, what does it mean by expected value. Allah khalik, Allah barak. See. So at the mass of sample increase, obtained concentration is getting near to the expected mass. In order to avoid constant determinant error, we have to take large quantity of masses. Allah khalik, Allah barak. See. Aywa. Finish?
Finish.
That's it.
Finish for today, teacher.
Yeah.
Thank you
And
for
now what you have to do, make practice of questions. So, this is revision of
The
statistics.
final, the midterm exam will include this week.
No, mid exam will be only chapter 1.
Only week 1, week 2, huh?
Yeah.
Okay, we need 1 day from you to brief us.
Okay.
Okay.
Tomorrow same time, mister?
I think this is better time because morning people are sleeping. This, that.
We are in the work, you know, mister, the day.
Yeah. So better it is this time.
Are you going to also explain week 4?
No, tomorrow we will explain study week 3.
So that means today you are explaining for study week 2, all that.
Yeah. All is study week 2. I summarized many things, so we can go through in detail. I uploaded all the things there, and also
teacher. How about week 2?
week 2, no?
ترى قال لك تو هذا week 2.
هذا week 2 تو.
ايوه اليوم شرحنا مع week 2.
Yes, sir.
Okay.
Week 2 study.
This is for week 2, huh?
Yeah.